Namaskar, my dear friends. Let us talk about thermocouple signal conditioning. What are the parameters that we need to take care of while designing the thermocouple amplifiers? We'll talk about both J-type and K-type thermocouples. Okay. So what we'll do is we'll try to take one of the IC from analog devices and we'll try to understand the features, the requirement, the design parameters, and as well as the block diagram. And according to that, we'll try to design the circuit as well. Okay. So what you can see is quickly I'll show you what are the different things that is available with us. So as you can see, I have taken a part number which is AD8495. There are various different part numbers like AD8494, 95, 96, 97. There are four part numbers in this particular series. Okay. So if you talk about AD8495, this is the full K type range for 0 to 50 degrees centigrade ambient temperature, like working. And some features we'll talk about soon. Now the best part of this particular IC that the reason why I have taken is it has the evaluation kit as well. So if you want, you can order this evaluation kit and you can try to test your I mean the amplifier or the you can test your thermocouple as and when required. Okay. Now if you talk about the data sheet, so data sheet is here and we'll try to explain you one by one, like what are the parameters, what are the things that we need to take care of, and our prime focus will be AD8495. Okay. However, for simplicity, if you want, you can use AD8494 as well. But since we have used, like in our application AD8495, that's the reason the focus will be on that. Okay. All right. So let us start. So as you can see from the data sheet, I told you like this is a precision thermocouple amplifier having cold junction compensation. Okay, so if there is a cold junction, it can compensate very easily. Okay, and you can see it is having very low cost and easy to design. So what are the parameters that you need to take care of before selecting a IC for thermocouple amplification? That we'll try to understand. See, so we can see here that we have pre-trimmed for J and K type thermocouples. You don't need to trim it separately. Then we have internal cold junction compensation. We have high impedance differential inputs. Okay, so it will not be loading. Okay, so this is very important, like high impedance differential loading, right? Differential inputs. It can be used for a standalone thermometer design, like it can give you 5 millivolt per degree centigrade difference, or like increment. So 5 millivolt per degree centigrade is very good amount. Okay, even if you send it to some ADCs and all, this is much more enough to detect by ADC. It has a reference pin which allows offset adjustment. So like if you want to set it to 0 degree onwards or 10 degree onwards, so like that you can set a reference pin as well. Then if you talk about thermocouple break detection, let's say your thermocouple has wire has broken. So in that case, this particular IC will help you to check that as well or detect that as well. Then we have laser wafer trimmed to 1 degree centigrade initial accuracy. Okay. Now if you talk about power consumption, then it is going to have power consumption less than 1 milliwatt. Okay, so if you have a supply voltage of 5 volt, it will be consuming less than 1 milliwatts of power. And the wide supply voltage range, that is the beauty of this particular IC that I have taken for my designs. So so what you can see is it can take a supply range from 2.7 volt to 36 volt, and if you have dual supply, then it will be taking plus minus 2.7 to plus minus 18 volt. Okay, now coming back to the applications of the ICs. So as you can see, we have several applications, like we have J type and K type thermocouple temperature measurement. Then we have set point controller, like you want you can set a particular point. There are various like Celsius thermometers these days, so you can use this IC for that purpose. We have universal cold junction compensator. Then we have white goods. White goods basically what? Like these days we have ovens, like micro ovens, a stove top, and all these things. So how to understand what is the temperature value so that you can like adjust your knobs or something like that. So this is very good like application with this kind of ICs. Okay. Then we have exhaust gas temperature sensing. Like you have exhaust fans, or like something like that, where high temperature gases are coming out. So in that case, you will be able to use this IC to measure the temperature of that particular environment. Then we have catalyst converter temperature sensing as well. Okay. Now coming back to the IC that we have used, so you can see we have AD849594, that is J type, then K type, then J type, then K type, right? And you can see ambient temperature range working is for 95 and 94, they are working up to 50 degrees centigrade. Okay. So the environmental temperature range should be within this. Okay. They will be able to measure temperatures bit higher than this, but this is the temperature range in which it will be working. Okay. If you want to go ahead with higher temperature range, ambient temperature range, then you can go ahead with 96 or 97. Okay. Now let us talk about the internal like diagram or understanding like what it is actually. So if you talk about AD8495 or 94 or any series of this IC, you will see that we have differential input like positive input and negative input. And in this, the pins have been also ESD protected as well as over voltage protection. Okay, so over voltage protection you already know, otherwise my pin will get destroyed, right? And as well as ESD protection. So ESD protection is actually given plus minus 4 kV only. Okay, but plus minus 4 kV is also fine. Now we have the thermocouple. So thermocouple is connected, and it has been like 1 mega ohm is connected here, so that if there is a breakage or something, it will be able to detect that okay, there is a break in this particular thermocouple. Now we have reference pins, so that can be like given a reference voltage. If you want, you can give it or ground it, and this is the amplified output voltage that you will be getting at this particular point to send it to your ADC. Okay, so this is how the complete like block diagram is there. This is the sensing pin that we'll talk about in our coming sessions. Okay. So as you can see, we have the what is that? Basically, it is an instrumentation amplifier. So you can see this is the gain block, and internally they have given gains of like 8494, 95, 96, 97. I think there is around like 97 gain is there, one of them, and one is 122 gain. We'll talk about that. Okay. And similar to that, after cold compensation, everything they have amplified, and then it is going to give you the output. All right. So let us talk about next. First of all, why don't we understand about this IC more, like what is given by the manufacturer? Then we'll talk about the specifications. So if you talk about this product highlight about AD8495, okay, 8495 or 94, all these things, let's say X. So it is going to have complete precision laser wafer trimmed thermocouple signal conditioning system in a single IC package. Okay, so this is how complete signal conditioning you can design in a single IC. It has a flexible pin out to provide operation as a set point or as a standalone Celsius thermometer. Then if you want to have a proper ESD, so you can see I told you like it has 4 kilovolt of ESD protection, right? And as well as it also provides over voltage protection up to 25 volt, right? So you can see like voltage input was plus minus 18 volt, however it can withstand up to 25 volt. The differential input rejects common mode noise on the thermocouple lead. So this is how it is going to avoid the noise as well, so you don't have to put a separate noise filter or something like that. Then it has separate pin voltage, uh, can be offset to 0 degree centigrade. That's what I told you. Like if it is measuring, let's say 10 degree centigrade to 50 degree centigrade, if you want, you can pull this down to 0 degree centigrade onwards. Okay. And it is very easy, available in very small and like 8 lead as MSOP package. Now let us talk about the specification. So if you see a specification, so like we have two grades, one is A grade, one is C grade. So C grade is little better, like premium quality you can say. So the initial accuracy that you talk about, so initial accuracy is this is 3 degree centigrade, but this is just 1 degree centigrade. So that's the reason I have chosen C grade, this one. Okay. Then ambient temperature rejection and all these things you can see about, like what is the like rejection values. So it is having 0.025 degree centigrade by degree centigrade. Then gain error is just 0.1%, and we have transfer function which is going to give you 5 millivolt per degree centigrade. That's the beauty. Like each 1 degree centigrade temperature increase or decrease or change, 1 degree centigrade or like 1 degree centigrade temperature change, there will be a change of 5 millivolt at the output. Supply voltage we have already talked about. And if you talk about the temperature range, so the temperature range you can see the like 8495 and 8494 is going to have 0 to 50 degrees centigrade. Let us quickly see the pin description so that we can have a proper understanding of how to design the circuit. So in that case, if we talk about the pin description, this is the 8 pin like IC which is having MSOP 8 package. MSOP 8 package, and you can see we have like negative input. So I will directly tell you, like we have negative input, this one we have reference. Okay, then we have negative supply. If you want you can ground it. Then we have no connection pin. We have sense pin, so you can see sense pin in a measurement mode connect to output, in set point mode connect to set point voltage. So if you want to set it to some other voltage or the other place, you can connect it to a set point voltage where you want to set it. Otherwise you connect it directly into the output pin, that's all. And similar to that we have positive output and we have positive input, and we have positive supply voltage, and then this is the positive input of the thermocouple. So negative is this side, positive is this side, and this is the output pin that is there. Okay. Now, if you talk about the like operations of this particular thermocouple, so you can see we have a thermocouple junction, and this is the wires that is coming out from the thermocouple, right? So what is happening is they are going to come to my PCB, and through a trace or something, it is getting connected to the positive and negative input of my thermocouple IC, right? So this thermocouple amplifier is going to introduce a little bit of errors due to this PCB traces. So our aim would be to keep these PCB traces as small as possible so that any errors can be avoided. And we have already talked about, like in detail, like what was the block diagram and how it is working. Okay. Now let us talk about the, like signal conditioning and transfer function and all these things. So if you see, the temperature that you will see at the output, is going to be V output minus V reference divided by 5 millivolts. So basically what is your output voltage minus what is your reference voltage, right? Divided by 5 millivolt will be the temperature that you will see at the thermocouple, right? So this is very easy or very like simple transfer function that you will be able to see to get your temperature of the environment or temperature of the thermocouple that has been like connected with, right? Now you might need or you might want to find out like what is my output voltage actually on at any temperature that we want to uh, like find out. Like let's say we have a temperature of 37 degrees centigrade. What is the voltage that you will be seeing? So there are two types, one is 94 and 96. So their gain is like 96.7 and 90.35. Similar to that we have 95 and 97. So in that case we have a gain of 122. Understood? So my output voltage will be TMJ multiplied by 5 millivolt plus V reference. So this is the output voltage that you will be getting. Okay. Now let us talk about next part. So let us say you want to detect the break. So let's say this is my thermocouple junction and we are having these wires, two wires, and they are getting connected to my amplifier that we have connected AD8495. So if there is a break here, you will not be able to understand whether there is a break or not. So in that case, if we add 1 mega ohm resistor to the ground, what it will do? You will see that it is broken. Then you will not be able to see the complete out input or of at this particular node. And this is how it will see that there is a open detection. Okay. Now coming back to the temperature range accuracy, so you can see all the ICs are having plus minus 2 degree centigrade, like maximum error, and their ambient temperature range is there, and you can see the temperature range measurement. So you can see for 95, what is there is minus 925 to 400 degree centigrade. Okay. So if you want to use it for like a little bit higher temperature range or something like that, this is the reason I have used this. Okay. Similar to that, if you want to make some Celsius thermometer or something like that, this is enough. Okay, minus 35 to 95 is enough. So in that case, AD8495 will be a preferred choice. Okay. Now let us talk about circuit design. So circuit design, this is the thermocouple wires that is getting connected. So what is going to happen? We have to connect when thermocouple tip type is not known. Okay, it means you will be using this to understand any kind of any kind of thermocouple that you want to add, it will be able to match it. Okay, and at the same time it will help you to detect the break as well. Then this is the series resistor that you will be using for filtering purpose. We have a like common mode filter and differential mode filter capacitor. So this is the filter circuit design that is there. So what is the filter frequency, like a difference as well as common mode, that you can calculate by using this 1 by 2 pi RC formula. Okay. Just make sure that the resistance value in the series that you are using must not be must be less than 50 kilo ohm. Okay, it should not be more than this. And at the same time, the differential capacitor that you have used must be greater than 10 times of common capacitor. Okay, so this is one thing. Coming back to the ground connection, so ground connection is always preferred. We have talked about several times, and you can keep it 100 kilo ohm to 1 mega ohm. Okay, so it's up to you, like how much current you want to waste towards this particular line. Higher the value, lower the current consumption in this particular resistor. So in that case, if you want, you can reduce the increase the value. If you reduce it, there will be a current sharing in this particular resistance as well. Now let us talk about some more connections. So if you see, this is the measurement junction, this is the reference junction where my PCB tracing has started. So your aim must be to keep this PCB trace as short as possible. Okay, so keep junction and the IC at the same temperature. So this particular junction and this IC, if they have to be at the same temperature, what is the thing that you need? You will be requiring to keep the PCB trace as small as possible. Okay. Coming back to the reference that you will be feeding. So reference, you don't do like you have 5 volt and then put a resistor divider R1 R2 and generate some 2 volt or 2.5 volt and send it here. No, this is wrong. Okay. The other method is make this 2.5 volt like this and then pass it through a buffer circuit. So this is my buffer, which will help you to give a proper reference voltage to the IC. So we will see this complete circuit design in our design implementation phase. So I will give you a complete circuit of our application so that you will be able to understand a complete circuit from beginning to end. Some other parts that we need to take care of is basic connections that you have to. So this is my IC that is there, which is having 8 pin, right? Now what is the first thing that you have to do? We have a supply voltage. So let us say we are going to give 5 volt supply. So for that you have to have a proper capacitors and filter capacitor. So if you want, you can have 10 microfarad capacitor, 10 LM capacitor or ceramic capacitor should be fine, plus 0.1 microfarad filtering capacitor. Okay, so this should be enough. Negative supply, if you want to give then only you provide, like capacitors, otherwise you ground it directly. Okay. So this is how. Then we have the reference point. So reference, you will be giving a voltage, or otherwise you will be grounding it. It's up to your requirement or your application requirement. This is the output pin. Output pin, I told you the sense pin must be connected directly to the output pin to have a proper output. That's all, like measurement mode. Okay. Coming back to the input side, we have the thermocouple. So thermocouple connection is here. Then we have two resistors in series for differential mode. Let's say R1, R2. And then we have the common capacitors and differential capacitor, and this is how a complete filtering circuit is being designed, and so that you can input your, like a signal to the positive input and negative input of the IC. So this is the, like instrumentation amplifier inside, which is going to amplify your, like incoming signal by 122 times. Okay. Now let us talk about next. So we have, let us say we want to, like design ambient temperature sensor. So basically kind of thermometer or something like that. So what will be the output? So output will be the the ambient temperature multiplied by 5 millivolt per degree centigrade. It means, let's say 30 degree centigrade is the temperature. So multiplied by 5 millivolt per degree centigrade, it means what will happen? You will be getting a value output of 30 into 5, that is 150 millivolt. So 150 millivolt will be appearing here. Okay. So you can see we have the output voltage of this much for 30 degree centigrade. Similar to that, 31 degree centigrade, you will be getting 5 millivolt extra. So that is 155 millivolt, right? So this is how you will be getting your outputs. Now, for different, like ICs, there are different, like what do you say? Basically, the transfer function is there. So there is an application note in the datasheet itself, and you can refer this. So you can see for 8494, this is the temperature measurement that will come up like 96.7. Then for 8495, this will be the temperature that you will be observing based on your output voltage and all these things, and it is having a compensation as well. So it is having 122.4 gain. Okay. Similar to that, 8496, this is the temperature you will get, and 8497, this is the temperature you will get. So if you want to see this particular, like application note, I will give you the like a link for that as well. So this is the thing that you will see. So see, you can see we have the temperature at junction, and which IC you want to refer, you can refer that. Okay. So 8495 94, then 8495, 8496, and 8497. So you can see for minus 260 degree centigrade, what is the like output voltage that you will be receiving. Okay. So actual output is this much that is coming. Okay. Similar to that, for other temperature values and all, you can see. So I think it is given 20 degree centigrade or 25 degree centigrade range. So it's not a linear value, like it is giving you a little bit of like a stepped values. Okay. And this complete, like application note gives you an understanding of how to use 8494, 95, 96, and 97 thermocouple amplifier ICs for your design. Okay. So this we have already talked about. So alright guys, what we'll do is in our next session, we'll try to understand the complete circuit design implementation that we have implemented in our, like applications. And if you do have any questions regarding thermocouple signal conditioning, or what is the kind of thermocouple that you are having, and you want to measure the temperature at the output with proper signal conditioning as well as amplification, and you want to write down the, like coding as well based on the or meeting your requirements, because you will be getting an output, let us say 120 millivolt you are getting at output. So you want to send it to your ADC. So which ADC will be superior, or which ADC will be applicable to that? Those things, those are the queries that you might have. So you can put down your queries in the comment box, and we shall be able to answer you out. Thank you so much.